In this video, you'll see how to use the distributive property. Remember the distributive property we use when we have a factor outside parentheses, and we can use it to multiply each of the terms inside the parentheses. So A times the quantity B plus C is equal to A times B plus A times C. I took that A and I multiplied it by each of the numbers inside the parentheses, and that's why we call it the distributive property, because you're distributing that A to the terms in the parentheses. Let's see how we could use this with some numerical examples. So I have 3 times 5 plus 7. If I use the order of operations, I'm going to add 5 and 7 first. I'll get 3 times 12, which is 36. But if I use the distributive property, I can also solve this in another way and still get the same answer. I can take 3 times 5 plus 3 times 7. That's a 3. And 3 times 5 is 15 plus 3 times 7, which is 21. 15 and 21 is 36. So I can solve this in two different ways, but still get the same answer. One way I can use this is with mental math. If I want to multiply 6 times 425, I can break 425 up into parts. So I can first multiply 6 times 400. I can multiply 6 times 25 after that. So 6 times 400 is 2,400. And 6 times 25 is 150. So 6 times 425 is 2,550. Now we can see how to use the distributive property to simplify algebraic expressions. In order to do this, I can take my factor outside the parentheses 3 and multiply it by both terms in the parentheses. So 3 times 4a is 12a. I drop down my minus sign. 3 times 2 is 6. In the next example, remember the commutative property. It doesn't matter where this factor is. I can change the order, still get the same answer. So now my factor outside the parentheses is at the end. I can multiply 6 times 7, and I get 42, plus, bringing down that addition sign, 6 times 4w is 24w. Down here at the bottom, just be careful when you're distributing with a negative number. So negative 10 is the factor that I'm distributing. Negative 10 times 5 is negative 50. Bring down my subtraction sign. That's between the 5 and the 3d. And negative 10 times 3d is negative 30d. I want to simplify this as much as possible, so I don't want to leave it as negative 50 minus negative 30d. Remember, when we're subtracting a negative, what we're really doing is we're adding. If you're taking away something bad, you feel better. So it's negative 50 plus 30d. And that would be my simplified answer. Finally, the last example, again, the factor I'm distributing is to the right of the parentheses, the terms in the parentheses, and that's okay because of the commutative property. So I'm going to take negative 8 times 11g. That's negative 88g. I'm going to drop down my addition sign. That's between the 11g and the 2. And negative 8 times 2 is negative 16. Again, I don't want to leave this as negative 88g plus negative 16. I know if I'm adding a negative number, I can simplify that a little bit more and write it as subtraction. Negative 88g minus 16. And then just a couple more to keep track of. Sometimes if you have an example like this where you have a negative sign outside the parentheses, you don't see a number to distribute, remember there's always that understood coefficient of 1 there. So even though we don't see that 1, the way you can treat this problem is as if there was a negative 1 there. So negative 1 times 6h is negative 6h. Drop down my minus sign. Negative 1 times 13 is negative 13. To simplify this even more, negative 6h minus a negative, really adding there, so it's negative 6h plus 13. Notice that with the negative sign outside, all you did was you changed the sign on the 6h and you changed the sign in front of the 13. And the last example, we don't have to just distribute with 2 numbers. We can distribute with 3 terms or distribute over 4 terms. There really is no limit to the amount of terms you can distribute. But the process is the same. So negative 4 times 5 is negative 20 minus negative 4 times 3n is negative 12n, and negative 4 times 7b is negative 28b. I can simplify this a little bit more. I get negative 20 plus 12n minus 28b. And that's how we use the distributive property to simplify expressions.